Hey friends, welcome to another episode on Go from the beginning. This time we'll talk error handling. Here we have a Go program. We can see in our Go program that we call a divide function with values 10 and 2. Let's try to run this code. What we're seeing is that we get a response 5 back, and that's fine. But what happens if we divide 10 by 0? At this point we get infinity back. Now, it's always a question of what we think our function should end up with when we feed it a parameter that we don't really know how to deal with. Well, in our case, we could argue that maybe, just maybe, we shouldn't allow for this to happen. What we did here on line 6 was to add a divider check. So if divider equals to 0, then we call a function called panic with the string that says can't divide by 0. This time around, we get a crash of the program because that's what panic does. Panic will crash your program and display the string that you provide to it, and it will also show you where the program broke down. This is a way to handle errors in Go, but you don't want to make sure that the programs crash out like this without some way of managing your errors. It's definitely perfectly acceptable to crash out the program if it's at a point where it can't recover. But you might end up with situations where, okay, I hear you, there is an error, I should probably log that error, but I want to continue. And before we continue, I wanted to show you a concept first called defer and how that works. We're going to add defer here to our code before we continue to talk about how we can recover errors. And I want you to notice that even though line 14 happens before line 15, line 14 isn't printed until the very end, as you can see here. And this is the defer construct that makes this possible because it says to run code last. That's what defer means. Now we've improved our code a little bit, and in our divide we now add this defer keyword that we just mentioned, and we're saying the very last thing to happen in this method is that you should call error handler. Now if we look at error handler, we see that it calls a method called recover, and this one helps us recover from a panicked state. So by using recover in this way, it will capture that error and it will be able to tell us like, look, everything is fine, I'm gonna print. So if we run this code instead, and now this time we can actually take this away and we re-enable this code. So we run this code. This time around it says recovered, can't divide by 0, and you can also see that it carries on with doing the division as it should. So using recover is the way that you should capture anything that is the result of a panic, and it should also happen last, so you should have it as part of a defer statement. Now as you have code that looks like this, that's able to throw out an error, it's able to capture it and make your program continue as normal, you want to consider one thing, is to make sure that you log this into a file. You can either log your errors or what have you into a file, or you can send it to a service. How you do it is exactly up to you, but next I will show you how you can be logging into a file. So here you can see how we are opening a file logs if it exists. So we're saying essentially that if you don't exist, create it. If you do exist, let's try to append. What it does is also, if there's an error trying to do this, then we are trying to print that error if we don't have the rights, for example, to create this file. And then we're using the log library to set an output with the file handler. And you can also see how log and OS was added, and this is a very nifty part of our environment that it adds the missing imports for us. Now for us to take all of this into effect, what we want to do is to add this line here. So we want to be able to use, right, so we need a way to make sure that we can log any errors, or rather it's a stack trace. So we're gonna add this, and this is us calling log and the println method, and we will give it the debug stack. So this is the position where the code is at when this happens. Let's try to run this, and you didn't see much, right? But know that we have set up the file handler to actually handle this. So we can see now that it should have been creating something to a file called logs, and every time we called logs with println, it should end up in that file. And if we look into logs, we see that it says can't divide by 0, and it's showing us all the needed stack traces for us to be able to track down and trace what the error is, where it happened. Now imagine this runner on a server environment. You can then go into a logs file and see all the various errors that occurred. Now this is a great attempt at trying to save down all your errors, all your info. You should probably have a more organized approach of putting this via a service or putting it into a database, but this is definitely better than just having your errors crash out your program. So this is what I wanted to cover so far about using panic, but also using some kind of error handler that uses recover, but also my recommendation that you should be using runtime debug to make sure that whatever error message that you log not only is the error message, but where it happened in the code, because if you tell the developer where it happened in the code, fixing any bugs will be so much easier. So let's switch gears a bit, because so far we've looked at how we can use panic and recover. Yeah, so let's switch gears a little bit and let's try to manage errors in a different way. And now you can see we start off with this method that says return a positive. If someone sends me something negative, I call a panic. Now, instead of doing it this way, what Go really wants you to do is to return an error here. So we need to augment this method to either return the value or return an error. So this is considered a better practice. So what that means is that you now have a second way to return something and to return an error. And you see here we either return the int or we return the error. And now you can see that I've already defined an error here, but you're kind of wondering what is this one coming from? Well, here's the thing with Go. We can actually define our own custom errors. By doing this, by calling errors.new, we're able to define our own custom errors. We can say number too small, and we can associate it with a certain string. So this way, by you creating your own custom errors, it makes your code readable. What I want you to see here is how we try to return. What I want you to see here is that we are returning, in fact, a tuple. So if we're saying if number is larger than 0, then we return the actual number, and as for error, we return nil. So there's no error here, right? And if it's less than 0 or equal to 0, we can see that we are returning the value, but we are returning number too small. So at this point, there is no value, but there is definitely an error being passed instead. Now you might wonder, how should I be calling this method? That's a great question. Now, you see me calling return positive here, right? And what the first thing I do is to say, okay, I got a tuple back, so number is number, error is error, and the first thing I do is try to inspect the error and say, if you're not nil, then I'm actually dealing with a error. But if you are nil, then it's fine to actually deal with the value. So if we run this code, it says the number is too small, and it does exactly what it's supposed to, right? Which is hitting this one. If we give it a number that's big enough, you can see how that error is not being hit. And this is really all I had for you today in terms of learning how to manage errors. You should prefer this approach over panic. The approach I'm talking about is you returning an error as well as the value in question, so that you always return a tuple essentially from an operation. So you should avoid using panics. Sometimes it makes sense for you to use panics, but the more Go code I look at, the more people are actually using this pattern here with the tuple, with the value, with the error. If you like videos like this, please give the like or a comment, or I would be super glad if you consider subscribing as well, so I know that you need more content.